Hello everyone, welcome to the new video. Today we are going to discuss the next chapter in our syllabus, that is mole concept and stoichiometry. The part mole concept is not there in our syllabus, so a very short part of the chapter is left out in our syllabus, so we are going to discuss that. So let us begin the video. The first thing we are going to learn in this chapter is what exactly are the gas laws. We have discussed that in class 9. We have read that in class 9. The two gas laws were there, that is Boyle's law and Charles' law. So we are just going to go through what were the laws. So Boyle's law stated that pressure and volume is inversely related, that is P1 V1 equal to P2 V2, right? Pressure and volume is inversely related, that is P2 equal to P1 V1 equal to P2 V2. How did we get? We knew that P1 is equal to 1 by V1, proportionality. Okay, so when we are putting an equal to sign, we are bringing a constant K. So we can write P1 V1 equal to K, right? Fine. So instead of 1 we can now put 2 also. So similarly this will now become this will become this will become this will become this. So both are equal to K, that means this is equal to this. Okay, this is how did we get. Okay, so this was the Boyle's law. What was Charles' law? Volume temperature relationship, right? Volume temperature relationship. Same way we will get the value if you do. Okay, V is directly proportional to T. They will be also equal to K. This part will also be equal to K. Ultimately, rest will be equal to K. Okay. So these two were the laws that we had learnt in the previous class. Okay, what we are going to learn in this class is the next law, that is Lussac'S law of combining volumes. Before we go to Lussac'S law, we have to know about what is meant by STP. STP means standard temperature and pressure. So what is the standard temperature that we will take? 0 degrees Celsius is equal to 273 Kelvin, right? And what is the standard pressure we will take? We can take the standard pressure as 1 atm, we can take it as 760 mmHg, we can take it as 76 cmHg, okay, or we can take it as 760 torr. Though we do not use torr, hardly we use torr, so we can take this at so many units, okay, but we do not use this torr there, generally we do not use, okay, so you can ignore this for now. These three are the main units that we need to use: 1 atm, 760 millimeter Hg, 76 centimeter Hg. H is mercury, right? Okay, so this is standard temperature and standard pressure. Okay, next we need to know about the temperature scale that we are going to consider here, that we have already known that we are going to consider the Kelvin temperature scale, right? The temperature case of Kelvin, that is absolute temperature scale. So what do we mean by absolute temperature scale? Absolute temperature scale is whose starting point is absolute 0. Starting point is absolute 0. That means 0 Kelvin. This temperature is called absolute 0, right? Absolute 0. What is absolute 0? Absolute 0 is the temperature at which all molecular motions will cease. That is practically impossible to get, right? 0 Kelvin. 0 Kelvin means how much you can imagine? Minus 273 degrees Celsius. Okay, this is a very tough temperature to achieve. Okay, so 0 Kelvin is not possible to have. Practically not possible. Okay, 0 degrees Celsius is possible, and it is. Okay, so this is the temperature scale that we will be using to do the Cauchy's law problems. We have already done also. Okay, now let's move on to the another thing that is called stoichiometry. The chapter has another part, stoichiometry. What is stoichiometry? Stoichiometry is basically the quantitative relationship to determine how many reactants, how much reactant, how much volume reactant, how many mole reactant, all that to calculate, both reactant and product. So quantitative relationship, that is said to be stoichiometry. Since we are bothered with a reaction, so we will say it as reaction stoichiometry. Okay, now let us straightforward go to Lussac'S law of combining volumes. Okay, Lussac'S law of combining volumes. You have to write whatever is written in your book. Lussac'S law of gaseous volumes. Okay. Lussac'S law of gaseous volume says that when two gases react, okay, when two gases react, we are considering two right now, but it actually not two, it's when the gases react. When the gases react, they do so in fixed volumes. They do so in fixed volumes that bear a simple ratio to each other and also to the volume of the gaseous products formed, provided that the volumes are measured under similar conditions of temperature and pressure. Understood? Understood? So when gases react, they do so in volumes which bear a simple ratio to one another and also to the gaseous product formed, provided that they all are measured under similar condition of temperature and pressure. So you cannot alter anything. You have to write exactly what Gay-Lussac has said. Clear? Now, how will you explain this Gay-Lussac? So it's a very simple one. Write any reaction N2, suppose this is the Haber process reaction, right? N2 plus H2 forms NH3. Okay, we have to balance the reaction first. Okay, so if we place 2 over here, this will become 3, right? So N2 plus 3H2 forms 2 NH3. Now, coefficient we are going to consider. What is the coefficient of this? Nothing is there means 1. So 1 volume. This is how much coefficient? 3 volume. Gives you how much? 2 volume. So this is 1 volume, 3 volume gives you 2 volume. This is Gay-Lussac's law of combining volumes. Understood? So ratio 1:3:2. It is a very complex ratio? No. Simple ratio. Okay. So how will the numericals come? Numericals will be asked from this part. Like suppose it will be given, let's take 2 liters of N2 is reacted with H2, okay, to give 4 liter of ammonia. Okay, instead I write the formula. Okay, so calculate this. Calculate volume of H2. How will you calculate? 1 requires 3. Remember how to calculate. Unitary method. Simple unitary method. 1 volume requires 3, right? Unitary method. So instead of this volume, we can write the unit that has been given. That is how much? 2 liter. So 1 liter can do 3 liter. So how much will 2 liter do? 6 liter. Understood? What we did apply? We applied basic unitary method. 1 volume can react with 3 volume. 1 volume can react with 3 volume. So here has been given 2 volume. So 2 volume can react with how much? 2 into 3, that is 6 volume, to give out 4 volume. Clear? So that is 4 liter. So this type of questions will be asked from Gay-Lussac's law of combining volumes. Okay, another thing, in Gay-Lussac's law of combining volumes, the volume of liquids and solids is considered to be a big zero. So if there is any liquid or any solid in your equation, that has to be taken as 0. If you consider the volume of solids, then it will go wrong. Okay. Okay. Now check a question I am telling. It is saying 6 liters of hydrogen. Okay. Let us take 6 liter of hydrogen. Fine. 6 liter of hydrogen and 5.6 liters of chlorine. A different concept will come up over here. I will tell you. 5.6 liter of Cl2. This reacted. Fine. And they are exploded. What will be the composition by volume of the resulting gaseous mixture? Okay, what will be the composition? So first thing, H2 plus Cl2, what will it give? Obviously it will give 2HCl. That is a gaseous state, not liquid state. You will be learning this in HCl chapter itself, that when direct synthesis happens, the formation is also a gas, not a liquid. Liquid is only in water. Okay, so this is a gaseous state. So 1 volume gives you 2 volume. This has to be seen properly. Okay, now check the thing. Understand, one volume can react with one volume. Think, suppose I have got 5 chocolates. Okay, I have got 5 chocolates. So I can give to someone 5 chocolates. Fine. Maximum 5 chocolates. Can I give 6 chocolates? No, I cannot give 6 chocolates. If someone tells me, give me 6 chocolates, can I give? No, because I have 5 chocolates. Now if someone asks me for 4 chocolates, shall I give 5 chocolates? No, I will give 4 chocolates. One will remain with me. Same thing will be applying over here. Check properly. If one volume will react with one volume, then check properly here. 5.6 liter will react with 5.6 liter. Can it react with 6 liter? No. Can it react with 6 liter? No. Why? The same logic I said. Extra, excess, it cannot react. It has to react with a definite quantity. Okay. So 5.6 liter Cl2 will react with 5.6 liter of H2 only. 5.6 liter of H2 only. So remaining H2 is how much? 0.4 liter of H2. Remember this value. 0.4 liter of H2 is remaining. Right? So 5.6 liter reacts with 5.6 liter to give this. So how many one volume gives 2? I'm talking now about HCl. So one volume will give you 2 volume of HCl. So this many volume will give you into 1 is 11.2 liter. So what will be the composition of the resulting mixture? What will be the composition of resulting mixture? 5.6 into is 11.2. So composition of resulting mixture is, answer you have to written like this. 11.2 liter of HCl gas and something else, 0.4 liter of unused hydrogen. Understood? 0.4 liter of unused hydrogen gas. So this here, this Cl2 has limited the reaction. So this is called limiting reagent. Okay. So a reagent that is completely used up in a reaction is said to be limiting reagent, because it will limit the reaction. This is completely used up, but the reaction could have proceeded had it been 6 liters, right? So it is limiting the reaction at 5.6 liter. So that is where limiting reagent comes. Clear? So if I had been told name the limiting reagent, then chlorine will be the limiting reagent. That you have to see the question whether there is a limiting reagent or not. Like here there is. Maybe some question might not be there. So you have to check whether limiting reagent is there in the question or limiting reagent is not there in the question. Then go for the question. Okay. Okay. So the Lussac'S law is done. Okay. Now let us move on to the next part. Next part is relative vapor density. Okay. Relative vapor density. This is new thing. Let us read. Relative vapor density is basically the ratio of mass of equal volume of gas and hydrogen. Fine. Mass of equal volume of gas and hydrogen under similar condition of temperature and pressure. Okay. Suppose let us write mass of element as small m. Sorry, not mass. Volume. That is, let us take V, and mass of this volume is m. It's a capital M. Okay. Volume of hydrogen is small v, and mass of that volume of hydrogen is equal to small m. Clear? So what did we define? The ratio of mass of equal volume, right? So this V and this V is equal. V is equal to V. So we can write this as also capital V. Clear? Why? Because two volumes have to be equal. So what will be relative vapor density? Relative vapor density, mass, that is capital M, of V divided by M of V. Both mass will not be same. Okay. Now Derivation of 2 into Vd relative mass is not there in the syllabus, but I'll just show it. Okay. So this is basically mass of equal volume of gas and hydrogen under similar condition, temperature and pressure. So mass of V by mass of V. Okay. Now how are we getting to that 2 Vd is equal to Rmm? Okay. See, okay, let's write first. So vapor density we have got, that is equal to mass of, let us take V volume. I am not writing at a similar temperature and pressure. Okay, that has to be there. Remember that. Okay, divided by mass of V volume of H2, and this is of let us take element X. Okay, let's say this is element X, right? Element X. Okay. Okay. Now next we can write Vd is equal to mass of V volume by mass of V volume. Volume is same. So we can substitute it using molecules. How and why? We haven't learned that part. That is called Avogadro law. Avogadro law states that under conditions of similar temperature and pressure, equal volume of all gases contain the same number of molecules. Clear? Same number of molecules. It is Avogadro law, none of them in syllabus, but we are applying the Avogadro law over here. So since their volumes are equal, number of molecules will also be equal. Clear? So we are substituting this with molecule. So mass of one molecule of X divided by mass of 2 atoms of H2. Now we will say, why did I bring it to atom? Just now I said molecule. One molecule of hydrogen contains how many atoms? 2. So we have written 2 atoms. Clear? We do not know how many more atoms are there in this element X, so we cannot write that. But hydrogen we know 2, right? Okay. Now Vd is equal to mass of one molecule. No need to write that. I am skipping one step. Mass of one molecule of X is what? What is mass of one molecule of X? Relative molecular mass. Relative molecular mass. Okay, right? So this is molecular mass, capital M, divided by what is the mass? 2. So we can write mass equal to Vd into 2. What type of mass? Relative molecular mass, or RMM. Clear? So this is 2, put that 2 there. So what is the answer? Molecular mass is equal to twice vapor density. Done. Okay. Okay. So this is mass of 2 atoms of H2 is 2 gram. Shifted that 2 over here. So let M equals to Vd into 2. That is what we will be using in, even in empirical formula. We will be using the same formula. Same formula in empirical formula. Okay. So this is the only part you are having from part B. Rest parts are not there. Okay. This derivation is also not there. Just you have to know that relative molecular mass is equal to twice into vapor density. Okay. Now moving on to the third part. That is empirical formula. Okay. What is empirical formula? Okay. Before we get into empirical formula, let us just discuss about percentage composition. Though we have discussed that in previous classes as well. See, learned. Okay. Percentage composition means how much percentage of element is there by weight, right? Okay. I am just showing one example. You all know how to do percentage composition. CaCO3. First we will see empirical, then we will discuss percentage again. Okay. CaCO3. So weight is 100. That is the total RMM. So RMM is 100. So if it is told calculate the percentage composition of every element, then you have to calculate this by this, this by this, this by this. So what is the weight of Ca? 40. So what is the percentage? 40 by 100 into 100. That is 40%. Ca. C. What is the C percentage? 100 into 100. That is also cut 12%. O. 48 upon 100 into 100. That is also cut, so 48%. Clear? So this is the percentage composition, and this is how you have to solve the percentage composition. See, add up, you will get 100. See, this is adding to 60 plus 40, 100%. Clear? So your answer is correct. Now every time you will not get this whole number. I have taken the compound in such a way that it is coming a whole number, but compound will be there which will come to decimals, and you have to calculate that. Okay. So I just showed an example. How will you calculate? Calculate the total atomic number 20 till atomic number 20. You have to memorize the atomic masses. Okay, it might be given, might not be given. In case it is not given, then it is not the question paper to be blamed, but it's to be you to be blamed. Why? Because you should have memorized it. Okay, so calcium is 40, carbon is 12, oxygen is 16 into 3. Why 3? Here 3 is there, but oxygen is 116. Clear? So this is percentage composition. Okay, now let us move on to the next very important part, empirical formula. Okay, what is empirical formula? Empirical formula is basically the simplest ratio of atoms of different elements, and it has to be the whole number ratio. So simplest whole number ratio of different elements present in one molecule of the compound is said to be empirical formula. Spelling is empirical. We say empirical, and you end up writing empirical. EMPERICAL, that is a wrong spelling. Empirical is a wrong spelling. Spelling is empirical. If you have writing problem, pronounce it as empirical. No problem in that. Okay. So suppose I write C6H12O6. What is this? Glucose. So what will be the empirical formula? Simplest ratio of this. That will be CH2O. Clear? So this is the empirical formula. So add up the masses in this case. What will it be? 12 plus 2 plus 16. That adds up to 30. Right? 30U. Clear? That adds up to 30. So this 30U is said to be the empirical formula mass. What is it said to be? Empirical formula mass. Clear? Empirical formula mass. And here whatever will be the answer, that will be the molecular formula mass. That will be the molecular formula mass. Clear? This is empirical formula mass. That is, in the empirical formula you add up the atomic mass of different elements present. That will be the empirical formula mass. Okay? Understood? This is empirical formula mass. Okay. Now there is a relation between the empirical formula and the molecular formula. How is that related? So I am writing in short. Molecular formula is equal to empirical formula into N. What is N? N is molecular formula mass divided by empirical formula mass. That is why I told you molecular formula mass. Okay. Molecular formula mass is always be greater than empirical formula mass. That is very common. So that has to be greater. So this will be divided by empirical formula mass. Whatever you get the value of N, that you have to utilize there. Okay. Okay. So these are the few things that you need to remember from this part. Okay. Okay, now let us do an exercise, sorry, not exercise, actually an example. So suppose there is given a compound contains carbon 40%. A compound has, it has been told that the compound has got carbon 40%. So you need to first know, and you need to make the table. Okay, table is very important. Okay, so let me try drawing the table. Okay. So here you have to write the name. Okay, next you have to write the percentage composition. Entire thing I am writing in short. Okay. Then you have to write is the atomic mass. Then you have to write is the atomic ratio. Then you have to write the simplest ratio. Done. These are the things you need to mention in your answer. Clear? These are the things you need to mention in your answer. The first compound I have told is C. Weight is percentage is 40%. Percentage 40. What is the atomic mass? 12. So now divide 40 by 12. How much will be the answer? 3.3 hopefully. 3.3? Yes, 3.3. So 3.3. 3.3. Okay. Achha. What else is given? Hydrogen is given 6.7. Hydrogen is given, that is 6.7. Hydrogen is given, that is 6.7%. Atomic mass is 1. Atomic mass is 1. So atomic mass 1. So here it will remain same, 6.7. No change in that. Why? Atomic mass is 1. Any problem? Okay. Oxygen 53.3%. Oxygen is given 53.3%. Atomic mass is 16. Now divide 53.3 by 16. How much will the answer come? Okay, 16, 3 are 48, 53, 3.3, yeah. More or less 3.3. More or less 3.3. 16 3 are 48 and 53 will come 3.3. Okay. Awesome. So what is the smallest number? We are going to divide everyone by the smallest number. What is the smallest number here? 3.3. So 3.3, 3.3. This will come 1. This will come how much thing? 3.3, remember 3.3, this will not come anything. Properly it will not come. Then we have to round it off. We will round it off and it will come approximately 2. Approximately it will come 2. 6.6 is actually the value. 6.7 we consider it as 2 only. Okay. This will come 1. So what is the empirical formula? What is the empirical formula? Write CH2O. Got it? Molecular formula have to find out. How will you find the molecular formula? N equals to empirical formula mass is divided. Sorry, empirical formula mass is below. Molecular formula mass is above. Right? So from here you cannot get the molecular formula mass. Why? Until you are given with the molecular formula mass. Are we given yet? No. So let me tell now 60. Okay. So molecular formula mass is 60. Achha, if molecular formula mass was not given, you could not have found out. Okay. Molecular formula mass will be given in the question if molecular formula is asked. So this is 60. How much is this? 30. Just now the 30. So what is the value of N? 2. So how what will you do? Add up, multiply this with 2. So what will it come? C2H4O2. Clear? C2H4O2. This is the empirical formula and this is the molecular formula. Clear? So this was all you need to read and practice the numericals from this part. Okay, though the main part is not there in the syllabus, but this part also is very important, and when you do, you have to make this table and make sure that you divide the percentage composition by the atomic mass and not the vice versa. Often you end up dividing this by this, that is wrong. To divide this by this. Okay, you have to divide the percentage composition by the next column, that is atomic mass. Okay. So that was all I had to tell from this chapter, mole concept. In the next video, we'll begin with the next chapter, that is electrolysis. Okay. So see you all in the next video. Hope you have enjoyed watching the video. Thank you.